everyone. My name is Juan, and today I'm going to be introducing our project for customer revenue analysis. Our team is made up from Farzam, me, Juan Álvarez, Sinan Lin, and Thomas van Dommelen. We are all part of the EIT Digital Master School, and this project is for data valorization subject. So the introduction. This project is going to be done using one Kaggle competition dataset, where we are challenged to analyze a Google Merchandise Store customer dataset to predict revenue per customer. We want to know the revenue per customer. Now, our goal, as I said before, is to predict the revenue per customer, and the data that we are going to use is going to be having the following columns: full visitor ID, channel grouping, date, device, geo network, social engagement type, totals, traffic source, visit ID, visit number, visit time, visit start time, hits, custom dimensions. Now, the dataset doesn't look very good. That's why we use the following function, this one that you can see here, to make it look better. To do that, we use the packages canitr and cable extra, which also I will mention later. This is the table we generated that I just named, and the libraries. These are the libraries that we use. I need to highlight that the data table, dplyr, tidyr, and JSONLate packages were used to manipulate and preprocess our data. ggplot2 were used to do visualization, and we use canitr, so R Markdown, and cable extra to present our result. And finally, check.packages is a function that can automatically check missing packages and install them. Thank you very much. This is everything for our introduction, and I hope you enjoy the rest of the presentation.
So, in the first step, we want to fetch our data into our R notebook by show head train data to see our first row and see what's the data inside our dataset. By glimpse command, we can show our table in the horizontal view. Observation is number of rows, variables is number of the columns, each column name, the data type of the column, and one sample data about the column. You can see in our dataset we have two columns related to date time. The first one is date and the second one is visit start time. Here we want to convert the data of these two columns to date type. The first one, date, was in a character, which we want to split and bring it into format of the year, month, and day. And the second one was epoch, millisecond time, and we use as date time to bring it to the POSIX data type, which is used to present calendar date and time. In some of the columns of our dataset, we have JSON. It's very hard to process the nested data in the columns, so we want to have the flattened dataset. We use the JSONLite library to parse each JSON and make flattened data and have the whole data in one row. Our dataset has too many missing values, and they are indicated with different kind of strings. We should firstly change all these different strings to one unique value, which is not assigned, or NA. After parsing JSON, we face one problem. Some of our columns just have one unique value, so it shows that these columns cannot have a very significant or important effect on our data while we are processing them. So we can drop the columns which has just one unique value in total. So we drop them. The next is that by parsing a JSON file, all the values are in the character or string type. Here in R we have characters. So we should convert these columns to numeric. And then by this pre-processing of data, we have a final result of our processing here, that we have one unique row which consists all the data. In the last part of the pre-processing section, we just want to visualize the missing data in our dataset. We use Cleveland plot and bar chart. First, we check the Cleveland plot. As you can see, some columns don't have any missing value, but some of them have too many missing values. But it's very obvious and we can describe it very easy because always all the data have the device category, date of visiting, or the browser from the user agent. But not all the data have the AdWords because not all the users come from the advertisement in Google or for example campaign, so not all the user came from the marketing campaign. So we go to the bar chart. We can easily see here that the missing rate in different columns.
Thanks Farzan, and I'm Lin. I'm going to talking about the part 3, data exploration. And let's first look at the target variable, the revenue. That's what we want to predict in the future. And let's first look at the distribution of the revenue. First, we need to do some pre-process. We sum out the revenue based on the visitor IDs, and we set all the missing value here to 0. And we reorder it and plot it. That's what we get here. You can see it's extremely skewed distributed. And the revenue mainly come from a few number of users. After that, we try to use the QQ plot, which is a graphical way to test the normality of random variable. You can see here the dots are not go along well with the line here, so we don't think the revenue, our data, came from a normal distribution population. And we try to use the log transformation on it, which is a commonly used tool for financial data. And after that, we got a quite good looking bell-shaped curve here. And then we try to use the QQ plot again. You can see in this time it's pretty well fitted, so we can roughly think that our revenue data is came from a normal distribution population after log transformation. And we also try to find the relationship, find the temporal pattern in revenue. Let's first look at the daily revenue. And we also plot the visits, but we are talking about this in the next part. And you can see the dot is everywhere, so we cannot see a very good pattern here. So let's look at the hour of time of data of revenue. You can see our revenue are mainly come from in this time between the 2 p.m. to 10 p.m. After that, we also try to find a relationship with the revenue and the channel. That's how the visitors came into our site, and also device, and also the geography feature, because it's an American store, so the revenue are mainly from the American visitors. And also the network domain, there's too many details, and you can look here, a lot of picture, and also traffic source. And I think that's all I want to say. Thanks.
Thank you, Sinan. I will now tell about the correlation analysis. Correlation analysis is a statistical method used to evaluate the strength of a relationship between two quantitative variables, which helps to figure out the relationship between numeric features and revenue. First, we select numeric features, because correlation analysis is used for analyzing quantitative features. Then we drop useless features, apparently things like user ID are numeric, but useless for modeling. And we also know user ID is not a real feature, so that should be dropped. Also, new visits and bounces are unique value features, NA and 1, so it should be considered as a binary category feature after one-hot encoding, and thus we remove it as well. Next, we calculate the matrix by the Pearson method, which you can see here. I want to emphasize on page views and hits because they have a really high correlation. Page view and hits are both the behaviors of users while on the site and look for anything, so it might be correlated with transaction revenue. Below are bivariate distribution plots of page views versus transaction revenue and hits versus transaction revenue. You can see them here. It seems like they do have a positive correlation. It's not that easy to tell from the cloud of points whether there is a relationship between hits and revenue and between page views and revenue. For the next step, we will fit a linear model to the data, indicate that there is some positive correlation between the two in both cases. To summarize, in terms of further work, we will employ some techniques of feature engineering, such as bucketing, missing data imputation, feature selection, and feature construction. Also, we will employ statistical regression methods such as lasso, elastic net regression, and other machine learning methods.